Hello, welcome to our session on why secure Amazon Web Services with AppGate. In this session, we're going to briefly explain some of the security challenges that come with embracing AWS and how adopting a software-defined perimeter approach using the AppGate product can significantly help improve your security and ultimately allow you to more easily and more widely embrace the use of AWS. So let's get started. We love AWS. Here at CryptZone, we use EC2 extensively on our engineering team, for QA, and for our solution architecture team. We're seeing many enterprises across the globe very strategically and very widely adopt AWS as they move from traditional on-premises data centers to cloud-based IaaS systems. This shift brings with it a tremendous number of benefits, but it also brings with it some new challenges, in particular around network security. If you look at how AWS approaches this, it provides security groups centered on IP addresses and not on user-centric access. This is at odds with how enterprises have built and designed and instituted their access controls over the last few years. If you look at these identity and access management programs and the business processes built around those, and the investment that organizations have made in role-based or attribute-based access control, all of those things are centered on users and not on IP addresses. This presents a challenge. If we look as well at the move toward the DevOps style environments where cloud services are continually spinning up and spinning down, that adds to the challenge of securing and providing the right level of access for users to those dynamically created resources. It's also difficult, for example, to distinguish business user access from administrative access and do things like ensure strong authentication or provide step-up authentication in various situations across different user populations, or even to log who has access to what for compliance purposes. If we drill into this for a moment, some real challenges show up. If I have a security group, for example, and I want to provide access from my corporate network, but everyone is NATed to a single IP address, I'm unable in my security group to distinguish those individuals. So everyone has to look the same and everyone has to get complete network access to all the resources in my VPC. And really, that's probably not what we want. If we try to map them to, say, our internal network IP addresses, that perhaps solves the problem in one area, but opens up a whole nother can of worms. Now, in the security group, I have to create dozens, if not hundreds, of rules. I don't know who these users are. These are just IP addresses, and I have users that probably have multiple IP addresses and multiple devices and IP addresses that change. We also have people with multiple roles. Someone who's a developer for one application is likely going to be a business user for another application, and really, we have no way of controlling access in any sensible or scalable way with this approach. Next, I have remote users. They may be working in a coffee shop, or they may be working at a remote office and have very specific access needs. This exacerbates the problems with security groups. I can, and in fact may well, use a VPN to control access to some of this, and that solves the remote access part of it, but it doesn't solve the access control problem. Because remember, all the VPN does is give you secure remote access and then puts you on the network. It doesn't control which resources you can get to behind that. So, of course, there is a better way. And the better way is what we call a software-defined perimeter. If we look here on the left side at how we're doing things today with source IP addresses and port-level access, there's a number of challenges around this that we just talked through. In particular, this is opaque. There's no notion of users in here, and it's a very static view of things. So let's take a look at what this software-defined perimeter is. The software-defined perimeter, or SDP, is a specification that's developed and published by the Cloud Security Alliance, a nonprofit industry consortium. And what it does is provide device-level and user-centric identity-based network access. Effectively, it's establishing an individualized and user-centric network perimeter on demand. This is what we at CryptZone call a segment of one. This reduces the attack surface because only those services that a given user is authorized to see will show up on the network for them. Everything else is completely invisible and inaccessible. What this does is it simplifies security. The security groups we looked at are a great example of that. It also allows for simpler network configuration and simpler network security because instead of working with opaque and static firewall rules, you're working with simple policies. We're seeing terrific uptake and adoption of the software-defined perimeter across the industry, with leading analyst firms like Gartner and Forrester included in their security models. leading organizations like Google talking and publishing about it, and enterprises like those shown in the lower right, publicly embracing and talking about using the software-defined perimeter underneath the Cloud Security Alliance umbrella. And I'm very proud that CryptZone is leading the software-defined perimeter initiative, studying and researching and publishing how this architecture can be used to better secure infrastructure as a service platforms. So let's talk about what this SDP actually is. What this provides, again, is this individualized perimeter that's dynamically set up based on user context. It provides very fine-grained authorization for both on-premises and cloud resources, and does this based on a simple set of policies that leverages user context and environmental context to make real-time decisions about whether a given user should be allowed to access a given resource. This has the effect of simplifying firewall and security group rules and turning what is very often a difficult and onerous process of managing IP address-based access into a much simpler one of managing user-centric and meaningful policies. Ultimately, this is all about ensuring and enabling secure adoption of AWS, which is what we're all about. So we saw this picture of what security groups looked like before, and with AppGate, the world changes. And now we're looking at a much more descriptive and much more easily understood policy around, in this example, allowing users to access ports 80 and 3389 for servers in the AWS VPC that have a certain tag, in this case the tag CSW demo. The set of users you can see through the drop-downs is dynamically selected based on certain attributes, whether the user is a member of a certain directory group, in our case sales engineering, whether the users are connecting from a particular IP address range, which let's say maps to our office network, or whether the user has an attribute called demo group associated with them. If we compare these two worlds, in the world of AppGate, we have policies that are simple and user-centric, and they're dynamically adaptable both on the user side as well as on the cloud side. If we look at what we're doing here is we're not targeting, in fact, any specific servers. We're using server metadata, in this case an Amazon tag, that determines whether or not a server falls into this policy. This is much simpler and easier to understand. Now let's take a look at how AppGate, in fact, is architected. There's three distributed components to this. There's the controller, which is the brain of the system, and which is the part to which clients authenticate, and then which issues tokens to those clients that contain a set of resources indicating the resources that the clients can access. There's a gateway that sits in front of protected resources and through which encrypted and tunneled traffic passes from the client device to the gateway and through to those protected resources. And finally, there's a log server which securely and permanently stores user activities for compliance, reporting, and forensic purposes. One additional piece which is really important is shown on the left-hand side here, which is the virtual network adapter. This is a small driver that installs in the client device and ensures that there's a secure and encrypted connection from the device to the controller and ultimately through to the gateway. This also allows the system to pick up and interrogate attributes on the client device in a secure fashion for use in policies. Much like a VPN client does, it provides secure remote access, but overall AppGate provides much more than a traditional VPN because it gives you effectively end-to-end protection and control and gives you a very fine-grained and user-centric access control mechanism. Now let's take a look at this in action. The user in this case needs to connect to a set of resources that are running in AWS in the lower right-hand side. When the user turns on their device, the virtual network adapter first authenticates to the controller. The controller performs then an initial set of policy evaluation as well as authentication and issues a cryptographically signed token that's sent back down to the client device. This token contains a set of resources and gateways to which the user is permitted access. Then, when the user attempts to access a resource, which, by the way, just happens as a normal course of activity, they run a client application or a browser or open up an SSH session, behind the scenes, that cryptographically signed token is then sent to the gateway in step 3. The gateway then performs a validation of the token and a real-time analysis of the policy behind it to determine whether or not the user is or should be permitted to get access to those protected resources that sit behind the gateway. Now the gateway may allow traffic through, it may block traffic, or the gateway may in fact need to perform some sort of remediation action, such as asking the user for a one-time password or asking the user to log for compliance purposes, the reason they need to get access to this particular resource. Assuming that the user is allowed in, the gateway opens up a tunnel, and network traffic then flows from the client's device through the gateway where it's taken out of the tunnel and then sent off to the resource on the right-hand side. This, in a nutshell, is how AppGate works. It implements the software-defined perimeter architecture and allows you to dramatically simplify your work with an easier approach towards securing AWS assets. Thank you for listening. The next video in the series will take you through step-by-step how to set up and use AppGate in AWS and get going. Thank you.